Good afternoon, everyone. Welcome to SWUG. My name is Sebastian, and today I'll be going over, for today's presentation, I'll be going over DFM, what exactly is it, and just giving some live scenarios on how to apply it to some daily products that we've seen in the past. Before I begin, I'll give a brief introduction. As I mentioned, my name is Sebastian, and I'm a lead mechanical engineer here at Interlink Engineering with over 12 years of experience applying DFM to various products across almost every industry to help save on cost, lead times, and quality without compromising on overall functionality. To add, I am as well a certified SOLIDWORKS professional and hold multiple professional certifications in various fields, as you can see below. Any questions before we move on? All right, perfect. Well, to jump right into it, what is DFM? Well, DFM stands for Design for Manufacturability and is the practice of designing products to simplify manufacturing, reduce costs, and improve quality and reliability without compromising on overall product functionality. So, as you can see below, the right image or the left image highlights a part design without DFM considerations, where there is a lot of unnecessary features and material requiring extended tool times versus the image on the right, which incorporates DFM considerations to help reduce overall complexity and reduce costs, as you can see. All right, moving on. So, why does DFM even matter? Well, DFM is crucial because it ensures that the design of a product is not only aesthetically pleasing, but also practical for manufacturing. At the end of the day, you don't want to give as an engineer, you don't want to give your machinist a headache. I've done it in the past. It's not fun. But by integrating manufacturing considerations in the design process, DFM essentially helps reduce costs by minimizing material waste, machining time, and secondary operations. It improves quality by ensuring fewer defects, tighter consistency, and better repeatability. It speeds up production by shortening cycle times and faster throughput. It enhances scalability by ensuring an easier transition from prototype to mass production, as you've already gone over all of the design considerations with your manufacturing team or other and such. And as well, it helps minimize risk. So there are fewer late stage design changes and manufacturing issues. Any questions before I move on? All right. So when applying DFM to any product or design, there are a number of considerations that need to be considered. First, when it comes to design itself, you want to try to keep it as simple as possible while being able to meet the functional requirements. So that means just avoid unnecessary complexity, features, and remove just any unnecessary features. If it's not needed, it's just kind of wasted space, which means most most of the time just results in um, additional costs. Second, always try to standardize and use standardized components, materials, and processes when possible. There are a number of existing components that are out there, and we don't need to reinvent the wheel essentially for what you're trying to get for 99% of the things you're trying to design. Third, when it comes to materials, you always want to choose materials that meet functional requirements, are readily available, cost effective, and suitable for the manufacturing process. Fourth, when it comes to process alignment and the actual design, you want to make sure that the design that you design per the actual aligned process requirement, and as well that the aligned process, manufacturing process that you align to the actual product itself aligns with the cost, volume, and overall requirements. Following that, you want to consider tolerance and fits. So when going more in detail, you typically will always want to try to avoid um, you only want to apply tight tolerance only as required. And just because the more tight tolerance you incorporate into the design, the more expensive and complicated it's going to get. That being said, when designing a part, you always try to just use standard fits and GD&T practices, um, just to help simplify, as I mentioned earlier. And finally, the when when designing these parts, it's a crucial part is always holding regular design reviews with cross-functional teams such as machinists, such as your manufacturing team, other engineering teams, and just get their feedback. Just get their feedback on how to improve your actual design for manufacturing. And then as well, as you're doing that, don't be afraid to rapidly iterate and fail because fail fast and win because that's how you're going to learn and that's how you're going to be able to design a part with all these with that incorporates all these DFM considerations. All right, any questions before I move on? All right. So, that being said, I kind of gave a brief overview of DFM, what exactly is it, and the and some key considerations to that need to be incorporated when actually designing a part. So I wanted to go over two scenarios where um, we apply DFM principles to a customer provided part that a customer wants us to design for them. So some background on this part. This is a bracket. Uh, this is a bracket for a connector that is meant to hold the connector for both the assembly and testing of it as I completely forgot to put in there, but anyways, some of the key requirements of this part was one, that it needs to be able to mount to a table while being able to rotate freely, and two, it needs to have mounting holes for the flange of the connector so it can bolt so that connector can bolt on um, to support the assembly and testing of it. That being said, the initial quantity of this part was our customer asked for a quantity of 50 of these parts to be machined out of ABS. So now that I kind of gave some brief background and you can see what this bracket looks like, this customer design looks like, what would be some things that initially stand out from your end that I actually I see you muted.
Things that stand out. It looks really pretty,
The
like
radius is
good
possibly
curvatures.
yeah. Radius is made up maybe a little bit of an issue, it seems like.
Yeah, exactly. That is one huge consideration. There is a lot of radiuses on this part, which will complicate the overall machining, and honestly, they're unnecessary. So that's one thing. What is another?
How about reducing all the fillets, eliminating?
Correct. So piggybacking off that, we could eliminate all the fillets, majority of the fillets, to because one, they're unnecessary, majority are unnecessary, and two, um, they just add to overall costs. So besides fillets, there's a couple more scenes that may make this not
Those counter bores
not s-
are really deep and out of position that you couldn't fix your part well to get to them.
And are they functional?
perfect. So other scene is the counter bowlers are that is a great observation. The counter bowlers are not necessary. All this our customer initially thought he wanted to counterboard it, but then after explaining that, oh, you can just mount mount your screw directly to a flat face instead of counterbore in it. He preferred that because it saved on overall manufacturing costs and uh reduce an operation. All
Uh,
right. So there's one more thing. Let's see if you guys
it
can figure it out.
is you have drafts on there or angles. Are those functional, or can they be straight sides? Because this is another setup.
So the draft is functional.
Okay.
This the actual brim or the flange of the connector is at an angle, so it just matches the angle of the connector so it can properly sit.
How about the length of the base? Is it needed to be that big
Ding
for
ding ding.
strength or not?
Ding ding ding, you got it correct. So yeah, the last thing is there's a lot of unnecessary material in this part.
Ted in
You
the
could
comments got them all right in one.
Oh, I didn't even see that. Perfect. So, just real fast, I'm gonna share my or go out of presentation mode and bring up the actual finished design. So, this is the customer provided part, as you can see right here. As we discussed, there are a lot of unnecessary fillets that just require, which extend machining time. There's unnecessary counterbores and as well unnecessary material. So that all being said, when simplifying and applying DFM principles to this design, we were able to actually um, optimize it, as you can see right here. So first, we took out all the necessary fillets. And the one fillet we did include was just right here, just to help with your tool path. Um, that being said, when it comes to the size of the fillet, you always try to aim for the largest possible fillet you can, but if there's a requirement or something needs to fit in here, you could reduce it. Second, we shrunk this down dramatically and as well added grates to the edges to help with your overall tool path when it's going through that first operation. Third, as you can see, we removed all the counterboards and just simplified it. So this is a flat face right here, and this is a flat face, thus taking away another operation. And then finally, this would be included in your drawings, but I just have it in the image. But I made sure to break all the edges because in the drawing that we provide to our customer, we'll just have a minimum edge break requirement. So what they would most likely do is just throw this part into a tumbler machine to break those edges, as you can see right here. Any questions?
So which are the operations that you would do for a CNC? So you'd hold it by the bottom there, right? Or are you starting with a rectangular chunk and then you'd want to drill down to get the lower platform?
Yeah, so how we would CNC this is we would start with a standard off-the-shelf block. So um, that is of this size. So what I did when I was reducing the overall length is that I just found a standard, I just reduced it to a standard block size that we could buy off the shelf. From there, we would do our first operation, which is just a pass of the overall profile. From there, we would then do a secondary operation to do or to machine in this angle. Third operation, machine down. You can machine down all of this, and then fourth operation is brewing in your holes as necessary. No, I could be slightly off on the sequence that I just described that in, but it just helped this new machine part reduce the total amount of operations from probably about 7 to 4. or two or three, sorry.
Okay, but if you were going to, say, mold this instead of machine it bits away,
All right. So that kind of, I guess before I transition, are there any more questions on machining machine design?
there's one in the chat.
Let me open that up.
I can read it to you if you like.
Sure.
It says, "Did you use SOLIDWORKS CAM for the machining?"
I personally did not. This is just I just modeled this based on general knowledge. However, when we do create a CAM program, a CAM program for this, I believe, do you remember what machine program we use and how
Interlink
Generally,
uses MasterCam.
Mastercam?
I believe that's right, Bob?
absolutely, that is correct. We use Mastercam internally.
So I think the order of operations here would be making something that can be built from a block off the shelf, um, deciding, what are the easiest ways to go about to bring this down to size. And like you said in the previous slide, working with a machinist who can tell you, oh, that part right there, that would be really tricky. And then putting it into software to see exactly what can be done and refining a little bit from there if you need to, right? Question mark?
I mean, yeah,
Uh,
that's a good summary of all the required steps. All right. Any additional questions on just DFM for a CNC part or on the first scenario?
Is there any requirement for that kind of circular boss, or could it all just be square on the bottom?
This?
Yeah. Nope, down. Yeah. Couldn't that all just be one big flat instead of a stepped area there?
Yeah, technically you could make it one big flat. Good point.
Alright.
Maybe the sloped face doesn't go all the way to the bottom of the base, so you have a flat to clamp onto.
That's another great point.
Could you explain like why that would be? Why you could get rid of those?
Sorry, get rid of what? I didn't.
I guess like because Luis had mentioned like you don't really need the top part. Could it just be like one solid part? Is that what he was kind of saying?
So he's mentioning, do we need this? If I just go from top down, do I need this step? Can I just fill in the rest of this material essentially and just have a hole? And to answer Luis's question, yes, you can. That would be another good way just to reduce the amount of operations or reduce overall machine time.
Oh, okay,
Do
cool.
you have it in there now from the customer's previous design?
No. So customer's previous design is just a block. It's just a stepped block like this. However, all he really needs it to do is he just needs material for your screw to sit on when it's bolted on.
Okay. Question from the chat. How did you set your tolerance for the CNC?
So when incorporating overall tolerance, you can just do a tolerance stack up of your related machining tolerance and tolerance of the actual connector, and as well any necessary tolerances required from the customer itself. On this part, it's more of a loose fit. He's not requesting a precise mounting locations and everything else. So we would just use standard tolerances when machining this.
Fun story, when I first started, I was really upset that we couldn't go zero, down to 0.0001. It's like, what the heck? It shows up that way in SolidWorks. I don't understand.
Yeah, and that kind of goes to one of the key considerations. Don't over tolerance if you don't need to. Um, there are going to be some products that do require some very tight tolerancing. However, if not needed, try to just stick with standard tolerancing, as it will help dramatically when it comes to saving on overall costs.
Can you talk about what would you define as standard tolerancing?
So standard tolerancing is typically plus or minus 5 thou on a CNC machine.
So
And then
not a 16th or a quarter inch, but like a little tighter still. Yeah.
yeah, then that's that as I mentioned, that's just standard. If you want to get tighter than that, that's when it will be paired with increased costs.
But great question.
Yeah, great question. All right. Moving on to the second scenario. Now, as Ashley kind of asked earlier, our customer wants to increase the overall uh, product quantity to 50,000 parts. Now, machining 50,000 of these brackets is not going to be very cost effective, as each bracket is probably going to cost around, let's just say, $100 to $150 each to manufacture. That being said, what we can do to address this and minimize costs is actually incorporate injection molding to manufacture these or to fabricate these. That being said, as I asked earlier, this design is not designed for injection molding, but my question to you is, what is it missing? And don't worry, I'll go over all of this after, kind of as I did before.
Probably equal wall thicknesses for injection.
Correct. So uniform wall thickness is a requirement for when designing any injection molded part.
Ted says missing drafts.
Correct. Um, Draft is the other one. Incorporating draft into design is the other. Right, there is one more. You guys did guess this earlier, so
Yeah, that looks like it's gonna need some side cores on either side.
correct. So it will need a side core when it's going to be molded. However, when it comes to the actual design, what else could be done to the design to optimize it for manufacturing or optimize it for injection molding?
Ted says material.
All right, there you go. So as we talked about earlier, there's a lot of unnecessary material to this part. We can basically just cut this in half and save on the amount of plastic required to actually mold this part. So, kind of jumping into SolidWorks. Uh, as you can see, this is your customer provided part right here. And then after applying DFM principles, you get a part like this. Now, first, um, first consideration is that we wanted to ensure that this part had a uniform draft or uniform wall thickness as well. And that being said, what we did is we cut off some of the material in the front face to help ensure a uniform wall thickness while ensuring that we still had this locating face that was already drafted. Second, we made sure to cut away all unnecessary material from the actual boss to reduce the amount of plastic required in this part, and which would help reduce overall costs. Third, we switched out that mounting boss for that screw mounting boss for an actual drafted boss feature right here that's more optimized for injection molding. And then finally, we incorporated draft in the actual design. So how this part will be drafted is how this part will be manufactured is you'll have a two-part mold with a side ejector pin to actually manufacture or to actually form these holes, as you can see right here. How it will, sorry, if I just draw a picture, or it's not side ejector pin, side core. So your first half will be like that, just covering this profile. And then your second half would be the bottom base. And you can have a hole. You can have it like there. It's kind of depends on manufacturer preference, but and then you'll have this side core right here that just goes in and out to form that hole. All right. So any questions on that?
I know we probably have a wide range of people here. Maybe go through why things need to be um, one thickness.
Yeah, sure. So when you're injection molding part, you want to ensure uniform thickness to ensure smooth and consistent flow throughout the part and help prevent any warpage due to unnecessary cooling and hot spots throughout the part itself, or faster cooling and hot spots throughout the part itself. So when you don't have a uniform thickness, it will result in a lot of defects such as warpage, sink marks, and and much more.
Okay. And to anyone who's still unsure, feel free to ask more questions. There is one in the chat that's where's your parting line and how did you join the part together?
So at the moment, I have this divided up in half. So basically, you'll do the full. You'll have the half of your actual mold eject from here, and then the other half eject from the top side. Then the other half just come up from the top side.
Okay. And I don't think that there is a mold that you can specifically show, which is why you drew it out.
Yeah,
But it's injecting from different places so that it fills the mold in all of the little crevices as much as possible, right?
correct.
Is there a reason why the bottom face doesn't have a radius?
We could definitely put a radius on there. At the moment, I just thought it was unnecessary. However, now that I think about it, it might help out when coming to reducing stress concentration and helping the part release when ejected out. So good point.
If you add a radius on that bottom surface, then you're going to have the split line halfway up that surface in order to get that radius into the bottom.
Great.
That is a great point.
Yeah, thanks, Jim.
Was there an advantage to, I guess, the bottom being kind of embossed like that for the mounted feature as opposed to doing just like a shell from a shell negative from the bottom. I guess the real question is why is this uh when I pictured the other part being injection molded, I figured it would be more of a shell from the bottom and it would just be kind of one thickness all around. Is it the cores that are preventing that on the left side or
So when you show this part, what will happen is you'll have some thicker areas when it comes to these side core areas. Because what will happen, if I'm understanding correctly, I can actually, let's see if I could just show it on here. Yeah, there we go. So as you can see right here, this is kind of what your shell feature would look like. However, you would have to fill in this material,
Mm,
which would lead to uneven uniform thickness.
okay.
I do have a question. Wouldn't you still, I wouldn't call it shell, but relieve the bottom so that it didn't have such a thick base, and then maybe you could cut up the that front face side a bit, basically kind of get a more uniform thickness because it looks like you've got this really thick areas on the front and the bottom, and then these nice thin ribs and like the where your boss is.
Yeah, good question. So for this part itself, we could reduce the overall thickness to match closer to the ribs, or I can increase the rib thickness is to match the boss. But my main consideration was to kind of just keep this main part at a uniform thickness of about 12 millimeters, and then when it comes to actually support ribs and everything else, that could be reduced. It could be reduced slightly when it comes to thicknesses.
Yeah, ribs are not actually supposed to be 1-to-1 to your body thickness. There is a ratio there. It's something like 60%.
But that is a great point, because there are some things that can be done to reduce material and keep the same strength that you're looking at. So that is great.
Yeah, I was just concerned with that 12 millimeters
That's
thickness.
thick.
You wouldn't mold that. You've had sinks all over the place. Probably warpage.
Yeah, we can definitely reduce it some more, but
Mhm. You could
there
even
comes a point
relieve
where oh
you could
sorry.
even relieve it from the top. I mean, there's just a lot of different things, but not down to the thickness of the ribs, but maybe 3 millimeter, 4 millimeters, something like that. Kind of throw that out there.
Yeah,
Absolutely.
no, great
I mean,
point.
you could be at 6 millimeter if the ribs are 3, and that may actually be a really good way of doing it too. Or 4, like you're saying, 4 because 1/8 inch is decently thick for a good injection mold too. Great feedback, guys.
All right, any additional questions on this? If not, all right, well, that concludes my presentation. Uh, want to give a thank you to everyone who was able to join this call, and as well to our sponsor, Impact Systems, MLC CAD Systems, and Go Engineer. That being said, if I just want to put this out there that we host office hours every third Thursday from 3 to 4 p.m. to help review any of your review any of your designs and help apply DFM principles as needed to optimize that design. So if you so yeah, thank you. That's all I have for today, Ashley.
Before we all go away, there's one more question from the chat about considering the load bearing for both CNC and injection. And then after we go through that, we're going to have sort of an open floor. We'll not plan to record, and everyone can ask any questions about ongoing projects or any other questions. Get some personal advice. Okay, proceed. Load bearing
Yeah,
for both CNC and injection.
Yeah, so when designing for both CNC and injection molding, yeah, there's a number of considerations. There's a number of ways you can reinforce the part to make it handle necessary loads that that it's undergoing. So for injection molding, you can add additional ribbing, as you saw in my image. You can increase the thickness, increase thickness slightly, and increase thickness slightly as well. For machining, you can get away with adding additional ribbing without all the necessary drafting and everything else. However, you do have to consider, and as well, increasing thickness. However, when doing that, the added features that you incorporate should accommodate a lot of the DFM considerations that I mentioned. The first thing is that it should just be very simple to manufacture.
The other thing that can be done is running FEA on these parts, which is not a bad consideration, depending on what you're seeing out in the field for what this part's doing.
Yeah, great point, Bobby.
All right, any other questions relating to this or not? Is anyone working on something cool?
Anything anybody would like to see on future SWUG meetings or get more information about?
Yeah, absolutely. We welcome all of the topic suggestions. Our next SWUG is going to be in person on Thursday, May 14th. Here at the Interlink office.
And then the next online version will probably be in another 3 months, or 2.5 to 3 months. I think what we're thinking. Ashley?
Yeah, I'm thinking probably around 4th of July-ish.
Great.
Somewhere around there. Oh, question of with this part that we've been working on, what if you wanted to 3D print it?
Yeah, great question. So, you definitely could 3D print it. However, when 3D printing it, you just want to make sure to include appropriate support features, and as well when it comes to 3D printing it, there's different orientations that you position can print the part to make it stronger depending on the force applications.
You want to pull up the model again? We can look at it.
Sure.
Even the printing technology you want to go ahead and consider, because you can go ahead and do more of a solid print out of PA11, PA12, or a standard FDM print. Go ahead and help you out too, depending on what you're doing with prototyping or in production. So if you were doing 20 or 30 of these, or 20 of them, maybe a 3D print out of PA12 may do the trick for you to go ahead and get you past what your needs are.
Yeah, great points, Bobby.
Would you have left it at the original CNC, or how would it have looked?
For just 3D printing it, I would most likely leave it closer to this design just because one, this will have the support ribbing needed, uh, and two, it reduces the amount of material that you need to print.
When you leave it like this, you can also do a honeycomb mesh on the inside, which will help reduce the material without drastically reducing the strength. The other thing to keep in mind, going back to the very first slide when you were collaborating with the machinist, the people buying the material really need to get with the machinist and find out how they're planning on holding something to machine it so that you make sure. A lot of times if you add an extra 16th or an eighth of material onto something so that you can hang on to it and then just do a simple skin cut in the end, that way you can completely machine your profile from one setup instead of having to do multiple setups to get all the way around the part. Sometimes that can really be worth the extra material, especially if the material is something inexpensive.
Yeah, great point.
I think with any of these designs or any of these scenarios, collaboration with your team from all those different departments is a great idea. Keeps you from being yelled at.
100%.
Assuming this, you'd mentioned that you'd most likely be sticking with this design shown on screen for 3D printing. For supporting kind of that vertical extrusion, would you really include those webs there for 3D printing, if assuming that's that print orientation you're going to go with, or would it be better to just increase that internal fillet radius?
I mean, you can do both if you really want to. You could increase the internal fillet. You could and remove. You can increase the internal fillet and as well incorporate these ribs to have it is to increase the safety factor. However, just depending on the application and how much force is applied, additional just the fillet alone might not be enough though.
Sure.
So it kind of just depends on how much force application or how much this part is exposed to.
And it also depends on the technology. Like I think like somebody was saying earlier, if you're doing the honeycomb inside of it, you may not necessarily be looking at a part that's like, hey, this is my production part if you're doing it out of FDM with the honeycomb. But you may be needing to still look at it and say, hey, I want to know how this thing feels, how it fits, how it works in the assembly. So sometimes those are great for prototype scenarios. On the second side of it, both of these parts or both of these versions would be good to go ahead and go out of PA12 because it's a solid inside or more solid inside. And you can use that to your benefit to see how it would function really well also, which we've done in the past with several scenarios to say, hey, how's this going to function when it gets made out of injection molding or when it's machined, if you can go ahead and do it relatively quickly.
And another couple questions in the chat. Are there any other processes you'd have used to manufacture these parts apart from the ones that we discussed?
Not these. For these parts specifically, I mean, some practices that we've already highlighted would to manufacture these would be just injection molding, machining, 3D printing for prototype or even low volume support. But those would be my main free manufacturing methods that I would use to produce these free. However, there's regarding other parts are a plethora of just various manufacturing processes that can be applied.
Yeah, for instance, you could make it out of parts of sheet metal welded together or bent up, but you'd get different problems, and it would probably take some welding with the extra thickness that you want in different places.
Exactly.
Absolutely.
Depends on what you're using it for and how many you want. Okay, next question is, how involved is the configuration table?
Oh,
See, you've got
it's
it open up right there.
sorry, it's not involved at the moment. It's just it just was automatically inputted when I created this.
I think it's more internally to show the different versions of the same thing. Normally, if you were just to make one for a customer, you could save it out as a revision, or you could make a revision in the configuration table, but it can sometimes, I think, be cleaner to have its own saved file, right?
Yeah, yes. And if you want as well, you can use you can link a bunch of various a bunch of different variables in your main SOLIDWORKS file in the configuration table and adjust via that configuration table to update all the various configuration models themselves. So saves you a bunch of time instead of having to click on each configuration and manually change them. I didn't do it for this application, but I have done that in the past to help speed up overall design time and as well reduce headache.
Yeah, good question, John. What else y'all got?
So in the beginning, he mentioned that on the edge brake that he was considering just throwing that in a tumbler and tumbling it, but he actually modeled an edge brake on the part. When you do that, if you go into your software for the deburring function or the chamfer function, that it's going to want to have a square corner there for you to pick for your tool path because it's based it off that square corner. So then, and if you use the chamfer function, at least in my software, then it will avoid corners where it would crash into something. So in my situation, I would have to go back and do a sketch line to run the chamfer around. And if you've already got it modeled into the part and you don't send me a file that I can suppress the chamfer on, if I was going to deburr it on the machine.
No, great point. I only have the chamfers or the edge braids unsuppressed in this model just to show you the visual of what the edge grates look like when you throw them into the chamfer. So the actual provided SOLIDWORKS part to you or to the machinist would have these edge grates just suppressed like that.
Great point, though.
Yeah, amazing point.
Did you do a cost comparison for the customer for each process?
Cost comparison, I did not. However, if I were to estimate injection molded part unit cost versus machine cost, you probably are saving about for a CNC machine part like this, it might be around 100. I'm guessing here, so go easy on me first. I would say maybe 100 $150 per part. Note that this can go down as your quantities increase. And then, however, for an injection molded part, you can probably get this part down to $2 to $3 per part. This is a pretty small part, so should be relatively the main expense would be just your tooling, which would probably be around, which would be initial cost of about maybe $5,000 to $10,000.
And that's just because of the cost of, you first have to make the mold before you can fill the mold and spit out a lot.
Correct.
So knowing from experience that it's going to take so long to make a CNC part, it's milled away, versus just making a mold and going, zoop, okay, done. Zoop, okay, done.
Exactly. And that kind of just ties back to one of the key considerations of applying your manufacturing approach. So when you're designing a part, you always want to consider the ROI in the manufacturing approach you select as well. So if Bob wants me to produce uh 5 parts, 5 of these, it doesn't make sense for me to get a mold made. But if he all of a sudden says, "Hey, I want you to build 5 mi or manufacture 5 million of these," then there's going to be a huge ROI in just getting that injection molded tool made and having these injection molded versus just CNCing. That was pretty dramatic, but yeah.
Are you the one doing all the considerations in your team, or are there people for each DFM/DFA considerations?
I mean, we all work as a team and hold joint design reviews to get everyone's feedback. There's some stuff that I may miss that other people can point out as everyone's done today. So I'm not the chief. I'm not the my way or the high. I'm not gonna manage by my way or the highway, but I'll get everyone's feedback and as we're going or as reviewing the design.
Very collaborative process.
Mm-hmm.
And that's a point where you can also, if you don't do machining or injection molding in-house, get your suppliers involved in some of these reviews to see if you can help them make their life easier.
If their
Because
life
on a
is
part,
easier, it costs less.
yep, and they're happier. So
That's what really matters.
That is
like
what really matters.
on a part like this, you could probably run 50,000 of them in a 4 or 5 stage or 4 or 5 pocket mold in 2 days. Whereas if you were doing this as a machining and 50,000 pieces, you're in it for weeks. They're great questions.
Yeah, super cool.
All right. Any additional questions?
Think we're good.
All right. Well, thank you everyone for attending this SWUG event. Really appreciate all the feedback and hope I was able to present some useful information to you all. Thank you.